Ah, there we go. Hello? Yep, that should do it. Okay, so we got audio back on the Twitch stream. We've got my webcam back on the Twitch stream, and we just need to deal with Discord. Are we gonna get back on Discord? Oh, I know. Okay, I got it now. I figured it out. The webcam app will only allow one application to take control at a time. So I'll tell you what. I like my happy mug on the Twitch stream, so I'll leave that camera going, and then I'll turn off the one on Discord because I'm into the chat group anyway. So it's not like I'm seeing you guys pop up. So we'll play it that way. Okay, cool. I'm building a clone army to take over the world. Building? Building? Do you mean built? Okay, let's get back right into it, right? So, what I'm going to kind of talk about is something that it took me a long time to sort of wrap my head around. And this idea of actors and containers. I think one of the difficult things coming from sort of a traditional CG background is you deal with compartmentalized, no stream on Discord. Hello. So you guys are not seeing the, I'm not streaming on Discord. Sorry, I'm streaming on Twitch, right? Can you guys see my stream on Twitch? Yeah, perfect. Okay, there you go. Okay, so one of the things that I'm used to in terms of working in a traditional CG pipeline is that, so you go Twitch instead. Oh, actually, one sec. I think I will be able to share my screen, actually. Let's do that. There you go. Because I think I can handle streaming on both. So you got a stream here on Twitch and a stream on Discord. How's that? You guys comfortable? You guys comfortable? You can see that? Really, the Twitch is just to sort of archive so you guys can refer to it back to it later. Yeah, I know. I don't know what has happened to me this second semester. First semester, I was right on the ball. Sit down to lecture, fire up Twitch, fire up Discord, fire up the web captioner, and away we went. I've just been really, really challenged this semester, and I have no idea why. I think I got a gazillion things going on in my head. All right. So, what we are going to do is we're going to take a look at how kind of Unreal compartmentalizes assets, packages them up, and well, how any game engine treats sort of assets. So we talked really briefly about this idea of blueprints being these separate containers, almost like mini editors, I think, that you can sort of nest inside of Unreal. So we'll take a look at a very, very basic actor. I'm going to actually delete this just so I can recreate it, and just so you guys are on the kind of the same page as me. Hello. Yeah, delete. Okay. So we're going to create a very sort of basic actor. Now, what I'm going to do is I'm going to come into one of these shadowed areas, sort of, maybe over here by where the box is. And then we'll stick a little kind of flickering light in here, right? Because we've been talking about lighting. Might as well just continue on that vibe. So I'm going to come in here and I'm going to create a blueprint, right? So the first thing I'm going to do is I'm going to right click and create a new folder, right? And in here, I'm going to put most of my blueprints, right? I've been struggling with how to organize my blueprint files. I've seen various different project structures. Some people will take a character blueprint and stick it in the character folder by the character static mesh. But I'm gravitating towards keeping all my blueprints in a separate folder, right? I haven't worked on any large-scale projects that involve blueprints because blueprints kind of came into its incarnation while I was here at the university teaching. So I'm not sure how a larger production would organize their blueprints. So I'm going to go with my instinct and keep them in a separate folder. In here, I'm going to create another one for lighting. And inside here, we're going to right click and we're going to go up to our blueprint class. Now, when we right click inside the content browser, we've got a few different things we can create. We've already created a level. We can create materials and we can create particle systems, right? But here we've got the blueprint class. Now, this is a lot different from these creation menus here. Different but the same. You can also you can create things via the right-click menu, or you can create them here inside the Place Actors menu. So something I forgot to mention last time, actually, is that there is a difference between the basic and the geometry mode. So you notice in basic, I can create a box, sphere, cylinder, etc. But in the geometry mode, we've got a box, cylinder, a couple of curved stairs and spheres, etc. So what's the difference? Well, I'm curious as to why the Epic guys chose to call this geometry. Because when you think of geometry, you generally think of static meshes and geometry that you create inside of Maya and stuff like that. But this is a special kind of geometry called BSP. These are BSP objects. BSP stands for binary space partition, but you don't need to know that. So what the BSP objects mean is that I can bring these in and I can edit them using Unreal Engine's brush tools, and I can change the shape of them and things like that. These basic objects are just static mesh, so you can't really edit them, right? But the static mesh, the icons being grayscale, also indicate this is geometry that you could have brought in from another package as well, right? So you could have imported this as an FBX or an OBJ from Maya, ZBrush, etc., etc. So that's essentially the difference. So I'm going to come in here and right-click, and we're going to create a blueprint class. Now it gives you a sub-menu, and what this does is it shows you the parent classes that are available to you. So those of you who don't know programming, i.e. my regular students, right? A class is sort of like a set of base parameters that you can kind of grow and extend and sort of build on. So the best way I can describe it is by talking about breeds of dogs, right? So you can have a dog class, but then you can instantiate that class and do something specific to it by creating, say, a collie class and a Chihuahua class, right? So they're all kind of based on the parent class of dog. It's basically that kind of thing, right? So there are ingredients that you put inside the parent class that would replicate to your instantiated classes. So if I have the parent class dog, I can say, well, look, bark functionality is in the parent class because the collie barks and the Chihuahua barks, right? If I went to the parent class dog and said, bark, but make sure it's a high-pitched squeaky bark, then the collie and the Chihuahua would both have a high-pitched squeaky bark. So you go, no, I can't put that in the parent class. I'll put that in the subclass of Chihuahua. Do you see what I mean? So it's just a way of organizing data and passing it around, right? So I'll talk a little bit about instantiating in a minute. Right? So if we float over here, the actor is the base class that you can create. I'm not going to talk about any of these. I'm just going to talk about the difference between an actor and a pawn. So an actor would be a blueprint that will spawn the minute you launch into your game mode. I'll talk about that. One of the big differences that you need to kind of be aware of is the difference between runtime and just being in the editor, right? Because there are certain things that become active the minute you hit play and the game is running that may not be active when you're inside the editor. So that's one sort of degree of separation that you need to be aware of when working inside of Unreal. The other is that this actor is something that can be spawned. The next one up is a pawn. And if you float over, the pawn is simply an actor that can be possessed, right? So there's a spawnable actor, and then there's a possessable actor. Spawnable actor, all it does is it just spawns in your world, right? Possessable means that not only can the player take control of it, but other things can take control of it. So for example, a camera could be a pawn, right? So the camera can spawn in the world, right? Be there and available to you as a player. But then when a cinematic launches, the cinematic can possess that camera and control it and do other things with it, right? So those are the essential differences. Character is like a pawn, just a little bit more advanced. Player controller is a pawn. That's even more advanced than that, et cetera, right? So we're going to create an actor, a very, very basic kind of class. So we're going to call this blueprint, and we'll call it light. And we'll have that. So now we actually have an object we can drag and drop into the world, right? But let's double click on this and open up the editor, right? So again, the blueprint class editor is very much like the Unreal Engine editor. It's like a mini editor. So we've got our outliner or world outliner here. These are our where we can add components and all kinds of stuff into our blueprint. This is like a mini 3D world where we can kind of see what it is that we're building, right? And then we have a couple of different areas here that we can play with. We have a construction strip, which we won't talk about today, and we got an event graph, which we'll talk about, right? So here again are the elements that you have inside your blueprint, like little functions and things like that. If we take a look at our event graph, I've got event begin play, event actor begin overlap, event tick, and we've got all these guys here as well, right? So this sort of, I guess it's more like kind of an outliner for all the nodes that you have currently available, right? And then of course, here's our details panel, which is the same as our details panel over here, right? It just gives us all of our dials and switches that we can play with. So if I come over into the viewport, right? What I can do is, actually, here's what I'll do. Just for the sake of bringing a mesh object in, let's come over here. So this is a cool thing. I can head over into my main Unreal Engine editor. There, right? And we're going to go into our contents, and I'm going to go into oh, actually, I wonder if I can drag it in from here. Can I drag it in from here? No, I can't. I don't have an object at the moment. You know what? I'm just going to skip that, and let's go to bringing just in a point light, right? But what we can generally do is if we have any mesh assets in here, actually, you know what? Screw it. Let's do it. Let's. I just want to show you this connection. So what I'm going to do is I'm going to create a real quick object inside of Maya that we can use as a torch for our light, right? So let's pop into Maya, and it can be any kind of 3D application. Doesn't matter what it is, right? I'm going to come over here. I'm going to delete all these guys. Right? And let's come in and create a polygon primitive cone, right? And then we'll just spin it around. That's fine. I'm going to come in and, oops, go to a transform menu, and we'll set this to 180. And also, when we're in any kind of 3D creation package, we have to make sure that our world is set to, let's go edit, file, no, Windows settings, preferences. We need to make sure that our settings in Maya are set to Z up, right? So the Z axis is considered the up axis inside of Unreal Engine. Do you guys know what that is? I know I did talk about it kind of briefly, I believe. Let's turn on the grid. I just want to get myself oriented here. I don't want to go negative values, so let's go 180. Oh. No thoughts on why Unreal Engine is C up? Lock.
So in the game export, you can just export things with the axis you want up in as well.
Yeah. Yeah, that's actually cool. I kind of, you'll find like these niggly little sort of things that I have in terms of playing things safe. You know, I've never trusted sort of procedural operations that happen in the background. And one of those things is automatic axis inversion on export. I don't know why I don't trust it. I think it's because a lot of procedural operations that I can't directly see or control have bitten me in the ass so many times in my career, it becomes difficult to trust the software. But yeah. Okay, so, whoops.
It's still good to match, so I think Maya and Unreal.
Yeah, I think so. You know, also, it's a matter of wrapping your head around it properly. Okay, Matt May says, no idea why. So the Z up axis is a number of different reasons. Now, I won't get into the coordinate system and left versus, you know, left hand versus right hand rotational mechanics. but one of the sort of more colloquial reasons is that most game developers design their levels on paper, and then when they're looking down on paper, they're looking at X and Y, and then the Z-axis is them looking down on the paper when designing, right? Whereas inside Maya, which is more for architectural design, right? The Y-axis always represents up in terms of architectural design. So those are some of the colloquial reasons for it, right? But it is no end of headache for me that 3D Studio Max and Unreal Engine are Z up and the rest of the world is Y up. But there we go. So we've set ourselves to Z up, and I'm going to go edit, delete by type history, modify, freeze transformations, because we want to bring this in at world 0, 0, 0, right? So now we've got a nicely zeroed out object, and here's one thing that will come and haunt you later on down the line, right? So is this torch ready to kind of export? Yeah, the Z-axis should always be depth, but it isn't. Don't get me wrong, I'm more comfortable with the Y-up axis and Z being depth, right? But there you go. It has to do with rotational mechanics as well, right? So the way they deal with quaternion rotations inside of Max, and I believe in Unreal, but I have to be sort of cited. I need a citation on it. But inside of 3D Studio Max, there's something called a TCB controller that calculates quaternion rotations slightly differently than any other package on the planet, and it all has to do with the order of operations in terms of which axis is calculated first, and then that's why the Z-axis is up to help facilitate that. I learned that the hard way, converting Maya assets into 3D Studio Max assets, animation assets, and that was a bit of a nightmare. It took me like days of researching before I found out that the quaternion maths in Max is slightly different to the quaternion maths in Maya. So there you go. Okay, so what is the problem with this torch? Well, what it is we don't know if it's the right size. You're just like, oh, well, it looks pretty big to me, but there's no scale reference material. But let's just export this out verbatim and see what we get. Now I'm going to come over here. I'm going to use the game exporter. Oh, actually, let's use Maya's built-in send to Unreal. Now the send to Unreal function is just using the same code structure as game exporter, right? It's just refined for Unreal. So I'm going to export all, right? And I'm going to choose my Unreal Engine project, which I think I created in here. Yeah, delete this game. And I'm going to go into the content folder. Now, I believe it creates a folder for me. I'm not entirely sure, but I'm going to try and force it into the props folder, right? Now, pop it in there, and I'm going to choose that directory. And I'm going to export this all, and then it opens up an FBX exporter. It does. It creates an import folder for me inside the props folder. I don't want that. I want it to go right into there, and I'll call this prop1 torch, right? And then we'll export, and it goes directly into Unreal Engine. We should, in a minute, see a change to source content has been detected. Would you like to import it? Yes. Right? And then it'll give me the FBX import options. You don't have to worry about it. Just click Import All. No smoothing group information was found in this FBX. Don't worry about it. That's okay. Should be all right. And if we pop open the props folder, we will get the static mesh or the geometry and an associated material. This always bugs me too, but I've learned to kind of adapt to this because they haven't changed this in a decade. But all the static meshes that you bring into Unreal, the materials will sit right beside it. There's no way to separate the two. I'm used to, again, an offline sort of pipeline where your geometry is separate from your shaders, and the shader team works on the shaders, and et cetera, et cetera. So it's brought in the default Lambert. That's my bad. I should have assigned a default material. Let's double click on this guy, right? When you double click on it, you get the mesh editor, and it's opening up beside my blueprint editor, right? Where is it? Well, let's hit the F key. There it is, and it's super tiny, right? The one big thing, other than naming conventions and directory structures, the one thing that you generally tend to work out in an early team meeting for a project is what your scale is, because you have to match all your software across your pipeline to that scale. Life has become a lot easier because we generally go, okay, let's match to real world scale. 1 unit is, a meter, and then we'll all do metric and et cetera, et cetera. But it is a worthy discussion to have when you are working with a team. So here we are, we're stuck with a very, very tiny asset, right? I'm just going to drag this guy into the world just to see what we're dealing with, right? And, well, yeah, that's really small, right? So I'm not going to bother fixing at the moment. I'm just going to scale this guy up. Well, actually, let us fix it, yeah. So let's bring it up to, say, 50%, right? So I'm actually going to go back into Maya. I'm going to come in here. I'm going to, not 50%, but scale it up by 50. So we'll go, let me do this in the channel box. It'll be easier. So I can just come in here, select those guys, hit 50, and there we go, hit F, right? And then I'm going to modify freeze transformations, right? So for all intents and purposes, any 3D package will look at that as scale 1, and then we will kind of export to Unreal again, send to Unreal. And, oh, I have to navigate to it again? That's crazy. All right, so I'm going to select that folder, and it's going to take me to the import folder. I'm going to go back out to the root where it says props, and I'm going to say overwrite that torch. So what should happen is in a second, it'll detect that change, it'll bring it in. Now, of course, it's applied my scale changes to it. So I'm just going to revert these back down to 1. Then when we hit the F key to frame up on that, now we're back to sort of normal, right? Okay, so let's stick our assets inside the assets folder. And I don't know, maybe I'll position this guy, something like that. Oops, I duplicated it. It's because I'm holding down the Alt key. Hey, I wonder if this will work. Bunk, yeah, it does. Cool. All right. Okay, so we got a piece of geometry, which is where I wanted to end up, because I want to come back to our blueprint editor. We're going to turn off our geometry editor because I didn't want to talk about that today. So here we are back inside our blueprint editor. I can come in here and I can drag and drop that torch in there. Now you can see that the torch has now been added to my component list, and it's now available to me to sort of work on, which is really cool. Okay, so we've added the mesh to the container. So we can add any kind of static mesh objects into the container, but we can also natively create things inside here as well. So we can do that like we do inside of Unreal by going to this add component, right? So I'm going to come in here, I'm going to bring in a point light. So there we go. We've got our point light, and I'm going to maybe bring this guy. Let me take this, and I'm going to move this to the root level, right? Because I don't want things to be parented just yet. I want that to exist at the sort of, I want to create what's called a flat hierarchy, right? So I want to make sure that they all sort of exist at that same level, right? So now I'm just going to compile this and save it, right? So it'll create this sort of blueprint object for me, and it's now available for me to kind of put into the world, right? So let's, I'm going to drag this guy off to the side because we're going to come back to him. And where I had the web captioner going, where did it go? There it is. Okay. Keep that guy there. All right. So now that we've got our blueprint, we've also got that torch in there, right? But we don't really need that anymore. I put that torch in there just to check the scale and the size. So how about we come in here and we delete that? It's still in our content browser. And if we come into our content folder inside here, in our Windows Explorer, and we go into the props folder, there it is. Now, what Unreal Engine has done is taken that FBX and converted it to its native file format .uasset, right? And when you go to package your game, it's going to strip out all the FBX files, so it won't bloat out your project. But there you go, right? So I'm going to come back out, and I'm going to say, look, let's go to our blueprint folder, because I created this blueprint light, which is a container that has my static mesh and my point light in there together, right? So we're going to drag this guy out there. Looks identical, but not really, because we get that point light, right? I might actually find a place where we'll get a little bit more of a dramatic sort of effect, sort of in the shadows here somewhere. Okay, cool. So we got that. I'm just debating whether or not. Yeah, okay. So let's continue forward. Now, the thing that I want to do to sort of explain to you the power of Actor Blueprints is add a little bit of an effect to our light, right? And what I want to add is a little bit of a light flicker to this guy, right? So this is why I kept the blueprint sort of open, so that we can kind of investigate setting that up, right? Now, to get this to flicker, you have to sort of think programmatically of what are the different steps that we need to create that flicker, right? So first, let me pop over the event graph, and I'll expand on what I'm talking about in terms of thinking about how you want to create that flicker. So inside the event graph, we have these nodes, blueprint nodes, that control what happens as soon as you hit the play button or as soon as you launch the game, right? So we have what are called events, and these events are like in-game, they're in-game events. They launch, again, when you play the game. So we've got event begin play, which dictates what happens once we start playing. And we've got event actor begin overlap. We won't talk about that. And event tick, we won't talk about that. This comes in handy a little bit later on when we're creating sort of real-time animation sequences. But we'll take these guys, we'll jam them down here. But the event begin play, this is where we can kind of think through what we want to happen the minute we hit the play button. Right? So the first thing I'm going to want to do is think about what the flicker does. The flicker will have a timing, right? Where it'll come on and off, and that timing, that delay between when the light comes on and off, we want to play with that a little bit. We want to make it random, right? So the first node that I'm going to bring in here will be a delay, a time delay, right? So I'm going to create that by coming over here to the corner and pulling out this wire. The minute I let go, the node graph gives me options of different things that I can create. Now, the biggest challenge for you guys is learning all the different nodes that are available to you. There's a huge library of different functions and nodes that you can access inside of Unreal, and I haven't learned them all. But what I generally tend to do, which I recommend for you guys, is just start building things, right? Following a few tutorials, learning what's kind of in there, and your knowledge will just expand in terms of the different things that you do, right? So I'm coming in here looking for delay. Oops, wrong kind of widget. That's the output delegate. What I want is what happens when we execute this node, right? So when we execute this node, i.e. launch it, the first thing it's going to do is it's going to look for a delay function, right? So we got a delay function here. We'll put that guy down. And we want, so if you're thinking about the flicker, when it comes down, it's delayed, but we want that delay to have a random number, a random duration, right? So down here, the first way I created a node was to drag a wire from the execute and drop it here by releasing the left click, and it gave me a list of options. The other thing we can do is something called tab typing. So once we're inside here, I can hit the tab key, and you can see I got the exact same menu, right? So in here, I'm looking for a random float in a range, right? So let's talk a little bit about this, right? So for having that flicker and that delay, we want a random value, but we don't want the random value to be like super long. Otherwise it'd be like, and then you're waiting and waiting and waiting, right? Because the values are just random. It could be anything. It could be like nanoseconds. It could be like hours, right? So we want to set a range. So a random float in range. And I think, what did I set initially? We can just set 0.5 to, I don't know, 8, something like that. Now, what ends up happening is this function, this random float in range, is kind of like a self-contained piece of computer code, right? That's basically what functions are. They're just like these self-contained calculations, right? And the node is like a visual representation of that. So inside this node, it's generating a random number between our min and our maximum, and it's producing a return value, right? So it's like, hey, I've calculated this. Here's the result. You want to take that result and you want to plug it into the duration and say, look, as you randomly calculate the duration, just put into the delay, right? And so now we've got a random value every time this delay sort of happens, right? Yeah, that's good. Just checking my notes here. I've got another step, but I don't know if, yeah, well, yeah. Okay, so this random delay is going to affect what? It's going to affect our point light. So we can actually drag that point light from here into our blueprint editor, and it creates what's called a reference. So I haven't actually dragged that light in. It's just a reference pointing to the light saying, you know, whatever happens here, I want you to affect this light object in Unreal, right? So in here, we're going to set the intensity of this light, right? Because that's what we want to flicker. So I'm going to come over here and let's do a tab type, and let's see if there's a set intensity. There is. So we've got a set intensity on a point light. So we'll grab this guy here. Oh, it's actually pulled in a point light connection for me. Just to play it safe, I'm going to delete that one, and I'm going to connect up my point light instead. Right. Just to be sure, I don't want it to be a situation where it's creating a reference of a reference. So I want the intensity also to be random, right? So currently we've got the timing delay, which creates our flicker, but I'd like the intensity delay to give us different variations of temperature. Now I can just take that random float in range again and just copy paste it, right? Just gonna copy paste it, and maybe the intensity, what do I got? 0 and 0.2. So let's go 0 and 0.2, although I think that's gonna be quite faint. So we're gonna let that calculate a random number and then plug that into the new intensity of that light, right? And once the delay completes its calculation, we are going to have that execute the set intensity. So here's what's happening, right? There's a delay in the time. Once it figures out that delay, it's going to set the intensity, right? So it's like really kind of thinking about the order of operations of objects you're trying to recreate in blueprints in slow motion and trying to figure out really slowly what event governs another event, right? So we're going to delay first. Once that delay is finished, then we're going to set the intensity, right? And then that's how that works, right? So here's what's happening now. Once the event plays, the function will come up with a random number, delay. Once that delay is finished, it's going to set intensity. The intensity has pre-calculated from a random float, and it's being driven by the point light, and it's going to set that intensity, and then it's going to stop. So you get like one Done, right? So what we now want to do is we want to take the result of after it finishes executing and come in and execute the delay again. And boom, it sets the intensity and then executes the delay again, and so on and so forth. And now we've got a loop, right? Now we got a loop that will work a little bit better for us, right? So we got two features at play here. We've got a delay and we've got an intensity, right? Both of them sort of being created by random float numbers, and they happen on event begin play. So it's nice to kind of neaten up your graph a little bit so that you can follow the logic a little bit more. And there we go. And it's all being kind of driven by the point light. Right? And so, let's see. No, I'm not going to get into manipulating the color, etc. Okay, so the last thing that we have to do is we have to tell Unreal to compile this. Now, the operation of compiling is sort of like translating. So everything that you do inside a code is human readable. Anything that you do inside of the Blueprint node editor is graphical and human readable. It needs to convert that into sort of a language that that Unreal understands and can execute quickly, right? That's what the compile process does. It pretty much translates it into code, machine code, and then we want to save it, right? So that's done. And the beauty of it is we've already placed our blueprint light into the scene, right? It's already there. But nothing's happening, right? Well, that's because now, when all's said and done, we have to hit play. And now, nothing's happening. Oh, it is happening, but my delay is a little bit strange. So that's okay. We'll go in and we'll re-edit that, right? So there was light and it's now gone off. We just need to come in here and we'll muck about. I think perhaps the delay is too big. So let's go 0.1 and 0.2. Let's go 0.01. Something like that, right? I'll compile, save, come back in here, and let's play this guy. I'm going to hit escape to come out here again, and then see if we can make other changes in here. Let's go 0.5. 5, and we'll go to 1. Let's try that. Skies here. Oh, the intensities are huge. Hang on a sec. Why are the intensities so big? Okay, let's try it. 1. Well, a really good rule of thumb in terms of troubleshooting stuff is that sometimes an effect, this is a good piece of advice, sometimes an effect is working, but it's so subtle you can't see it. I don't know how many times that has happened to me in compositing, in compiling textures and working with textures, and in lighting, right? So sometimes the best way to kind of figure out if something is working is to crank that value range up really, really high. Just to see if the thing is working or not, right? So let's come back here. Hopefully that'll do it for us. Hey, there we go, right? Probably the intensity had to be that high in combination with the sky sphere. There's a lot of light coming into the scene. So to make a dramatic impact, we needed to get that value up relatively high. right? Now notice again, this is only working at runtime inside the blueprint. When I hit escape to stop the Unreal Engine, we're back in the editor, and that light intensity is consistent, or constant rather, right? So let's come in here. I want to crank this up actually a little bit higher. Let's go 5,000, and the minimum would, right? Compile and save. We can come in here, and then we can run this again. Yeah, that barely made any difference, right? But that's cool. We can also come into the point light itself. We can select it in here because it's an object that we can also edit the details on here, right? So we can come in here and we can change things, like we can come in here and add a light color, right? Then we can compile it and then save it. And then when we come up here, we can just hit play. And we got a little bit of, you see it more at the base, right? But we can see that there's a bit of color kind of happening there as well. So that's it. Really just wanted to kind of run through a very, very simple example of how to use blueprints and how to utilize them. Now, again, the benefit of a blueprint, now try and think of it this way. What a blueprint allows us is a procedural way of putting in an animated effect, at least for this, right? So can you imagine if we wanted to animate that flicker inside of Maya, we'd have to go through and play the intensity slider and then hit keyframe and the intensity slider again, hit the keyframe, move up the timeline, et cetera, et cetera. It would just be annoying, right? So this is more of a way of creating a procedural operation to create that flicker. You don't need to hand animate a flickering light because the result is sort of random, right? So yeah, again, we're utilizing a random number generator to kind of create that timing delay and a random number generator to create different intensity values. That's all we've done here. And then we've looped it so it goes on continuously, right? And I think I'm repeating myself now. So that's it for that. Yeah, that's cool. So what I'd like you to do is to kind of have a go at, I'm going to leave this blueprint up just because it's a good sort of visual guide or visual reminder. And I'd like you guys, especially those of you with no experience with blueprints, just to try to create a flickering light. You don't even need geometry. In fact, at the top of this session, I wasn't going to create that cone. I was just going to bring a spotlight in, right? Because if you think about it, look at this blueprint. There's no reference to geometry. It's just a spotlight, right? But at the last minute, I'm like, oh, you got to have a bit of geometry there just to kind of make it a bit more visually interesting. So give that a go. We've already done the building of a lighting solution. Now you're using blueprints inside of an actor to create more dynamic lights, right? So any questions about that at all? Nope, silence out there. Cool, okay, I'll leave you guys to it. I'll give you, I guess maybe half an hour to muck about with it, and then I'll check back in and see where you guys are at. Sound good? Yeah, sounds good. Okay. Okay, cool. All right. I will talk to you guys later.